Something strange is happening in the vastness of space. Our solar system, this delicate dance of planets orbiting the Sun, moving through the galaxy as a cohesive whole, is veering ever so slightly off course. It's subtle, almost imperceptible, but it's there. A mysterious force is tugging at us, pulling everything: the Sun, the planets, the moons, even the Oort cloud at the farthest edge, toward something we can't yet see. Astronomers call it a gravitational anomaly. But what if it's something more? What if an unseen giant is warping the very fabric of space-time, shifting the trajectory of our solar system like a cosmic hand, steering a ship through a dark ocean? This shouldn't be happening. According to everything we know about gravity, mass, and motion, our solar system should be following a predictable path around the center of the Milky Way. But it's not. For decades, scientists have observed a strange acceleration, an unexplained drift, a pull coming from a region of space where, by all accounts, there should be nothing. No stars, no black holes, no galaxies, just darkness. So, what's out there? Could this be the shadow of a force we've never encountered? An undiscovered structure at the edge of the observable universe? Or something even more bizarre, like a tear in space-time or a hidden dimension bleeding into ours? In this video, we'll uncover what was really discovered and why it could change everything. The first hints came from deep space surveys, where scientists were meticulously tracking the motion of galaxies and mapping the large-scale structure of the cosmos. As part of the Cosmic Microwave Background (CMB) studies, those ancient fingerprints of the Big Bang, astronomers noticed something odd. The CMB appeared slightly distorted in one direction, as if something massive was dragging our entire galaxy ever so gently toward it. They called this phenomenon the dark flow. Using data from NASA's Wilkinson Microwave Anisotropy probe, researchers realized that clusters of galaxies across a vast region of the sky were all drifting in the same direction, toward the Hiu edge of the observable universe. It was like watching hundreds of leaves floating on a pond, all pulled by an invisible current toward something behind the curtain of reality. But what could do that? There shouldn't be anything powerful enough or close enough to cause such motion. This discovery wasn't just surprising, it was unsettling. It directly challenged the foundational principle of cosmology, that the universe on large scales is uniform and isotropic. In other words, no direction should be special. And yet, here it was, a preferred direction, a pull. For years, skeptics called it an error, a glitch in the data, a misinterpretation. Telescopes were recalibrated, simulations were rerun, but the anomaly refused to disappear. The more the data improved, the clearer the signal became. And then the breakthrough came. Hidden in the background radiation, beneath the noise and static of the universe's earliest light, a pattern emerged. Faint, consistent, undeniable. Something massive, far beyond the known structures of the cosmos, was exerting a gravitational influence. But what could it be? An invisible colossus? A cluster of dark matter too vast to imagine? Or something we've never even conceived? Whatever it wasn't supposed to be there. To understand the mystery behind the pull on our solar system, we need to dive into some deep cosmic physics. Imagine space as a vast, stretchy fabric, like a giant trampoline. When objects with mass, like stars, planets, or black holes, sit on that fabric, they create indentations or dips, bending space around them. This is the essence of gravity, as described by Albert Einstein's theory of general relativity. Mass and energy warp spacetime, and this warping is what causes objects to move. In simpler terms, the heavier the object, the deeper the dip it creates in the cosmic fabric. Now, scientists have long understood that the gravity of nearby stars, galaxies, and clusters can influence our solar system's path. But this recent, Anomaly points to something much bigger. It's as if our solar system is being gently pulled by a force much farther away than anything we can currently see. The question is, what is causing this distortion in space-time? Using advanced space telescopes and sensitive instruments like the European Space Agency's Gaia probe, astronomers have been measuring the motion of distant galaxies with unprecedented precision. They've found that the Milky Way, along with thousands of other galaxies, is drifting toward a strange, unexplained point in the sky. The object, or phenomenon, causing this isn't emitting visible light, which rules out stars or known galaxies. It's not even detectable through traditional means like X-rays or radio waves. This made the discovery so difficult. It wasn't just hidden. It was actively avoiding detection, but scientists didn't stop there. They observed that the gravitational pull wasn't just distorting the path of galaxies. It was also affecting the cosmic microwave background radiation itself, the faint glow left over from the Big Bang. The radiation showed slight shifts in frequency, suggesting the presence of an invisible mass exerting a subtle but constant tug. This phenomenon is not just an isolated mystery. It's a gravitational signature. Something with mass, yet invisible, is warping spacetime in a way we had never imagined. Perhaps it's a supermassive black hole far beyond the reach of our current instruments, or maybe a giant structure of dark matter, an enigmatic substance that makes up most of the universe's mass but doesn't interact with light. Here's the aha moment. The pull on our solar system might not be some random event. It could be evidence of something we've never thought possible, a giant, unseen cosmic structure hiding just beyond our reach. And that's not just mind-bending, it's revolutionary. This discovery goes far beyond just an astronomical curiosity. It offers a potential glimpse into the very nature of the universe itself, and its implications are profound. The fact that something so immense and invisible is influencing our solar system suggests that there's much more to the cosmos than we ever imagined, things we cannot see, measure, or even begin to understand. This mystery could hold the key to answering some of the biggest questions humanity has ever asked. How did the universe begin? What is the true structure of reality? And, more fundamentally, what is our place in it? If this gravitational anomaly is indeed tied to an ancient structure or an unseen force, it could shed light on the first moments of the universe, those chaotic, uncertain seconds after the Big Bang. This might be a clue that what we see today is just a fraction of what existed in the early universe, long before stars and galaxies began to form. It's like discovering a forgotten chapter in the cosmic history book. This isn't just a particle, it's a window into the first moments of time. Furthermore, this pull could alter our understanding of time and space itself. If there are unseen, hidden structures exerting gravitational influence from the edges of the observable universe, what else is lurking out there? Could there be entire regions of space that we cannot even imagine, existing just beyond the threshold of our detection? And if there are unseen forces shaping the cosmic landscape, what does that mean for the future of our own solar system? Will our solar system continue to drift toward the unknown, perhaps even merging with something far more extraordinary in the distant future? This discovery forces us to confront the possibility that the universe is far stranger than we've ever realized. It's a reminder that we are not merely passive observers in the vastness of space. We are participants in an ongoing cosmic drama, with forces at play that shape our very existence. The universe is telling us we still have so much to learn, and perhaps, just perhaps, the answers lie hidden in the dark corners of the cosmos, waiting to be uncovered. The path that led us to this astonishing discovery began centuries ago, with the birth of modern physics and our understanding of the cosmos. It all started with Isaac Newton's law of gravity in the 17th century, where he revealed that every object with mass exerts a pull on every other object. But it wasn't until Albert Einstein's theory of general relativity in the early 20th century that we truly began to grasp the idea of spacetime itself, an interwoven fabric that bends and warps under the influence of mass and energy. With general relativity, the universe became a dynamic, changing entity, far more complex than we could have ever imagined. Fast forward to the late 20th century, and breakthroughs in quantum mechanics and particle physics began to add layers of depth to our understanding. The discovery of quarks, the building blocks of matter, helped explain the inner workings of atoms. Then, in 2015, the detection of gravitational waves, ripples in spacetime caused by violent cosmic events like colliding black holes, cemented our understanding that the fabric of the universe is far more sensitive and dynamic than we previously realized. Now, with this newfound anomaly pulling at our solar system, we stand at the edge of yet another revolution. What if this hidden mass is a key to unlocking the mysteries of quantum gravity? A theory that seeks to merge the strange microscopic world of quantum physics with the vast cosmic scale of general relativity. Or could it provide new insights into time travel, revealing pathways through spacetime that we've only dreamed of? Looking ahead, the discovery could open the door to entirely new elements of physics, potentially uncovering previously unknown forces, particles, or even dimensions. It could change everything we know about the fundamental nature of reality and our place within it, just as the discoveries of gravitational waves and quantum theory reshaped our understanding of the universe. What lies ahead may be even more mind-bending than what we've already uncovered. We are now closer than ever to understanding the birth of the universe. This discovery, this elusive pull, takes us to the very edge of what we can comprehend, a frontier where science and imagination meet. As we peer into the dark void, the unseen force drawing us forward, we are reminded that the universe is alive, moving, shifting in ways we cannot yet fully grasp. In the silent dance of quarks and plasma, we may find the truth of everything. The origin of time, the beginning of all things, hidden within the vast, intricate web of the cosmos. It's a humbling thought. The more we learn, the more we realize just how little we know. Each answer unearths 1,000 new questions, each discovery, pulling us deeper into the mysteries of existence. What if the universe is not only stranger than we think, but stranger than we can think? And this might just be the beginning. If this blew your mind, hit like and subscribe for more cosmic journeys. Got your own theory or idea? Drop it in the comments. Until next time, stay curious and keep looking up. The universe has a lot to reveal, and we're just getting started.